All right, so before we get going on the robot project, I think it's good to start with some definitions and talk about some terms that we're going to use in the course.
Yeah, I think that's a good idea. This is a pretty short video, and it's really just to set some words that we'll use and some sort of unit terms that we'll use so that you can follow along and not worry too much. First distinction that you may hear us throughout the videos talking about is maybe this sort of analog versus digital. What is the difference between an analog and a digital circuit? And the answer is that increasingly these areas are merging, but let's give you kind of a canonical overview of what usually circuit designers think of as the differences. So starting with digital, digital circuits represent quantities that they work with as binary numbers.
Yeah, so that means binary numbers are numbers where you only have zeros or ones, right?
That's right.
So that's what a binary number might look like.
Right. Our numbers in daily use are base 10, so they go from 0 to 9. A binary number will go from 0 to 1. So digital circuits perform logical operations on these binary numbers. What's inside them are transistors, which we'll talk about later in the course. And these transistors are really just manipulating two voltage levels, a voltage level that represents a 0 and a voltage level that represents a 1. And don't worry too much if you're very new to this, you're not quite following along. Just remember that within a digital circuit, you're really just manipulating the primitives. The basic devices are just manipulating these zeros and ones, and they're just doing logical, like an and an or operation. And you can build those up, these logical operations, to do more interesting things, like, for example, math, right? You can subtract and add binary numbers.
So computers do, right?
That's what computers do.
That's why we call them computers.
Exactly. And if you're good at programming and if you've been doing this for a while, you've eventually got a feel for doing all this. You can, of course, build memories, which store these digital zeros and ones. And the last two are really important for those of you thinking about this as a career. Digital circuits are very modular and composable. That means that you can, using these logical rules, you can really break up the logic of how they're put together and come up with really robust rules for how to put them together. They're also very easy to automate. So modern sort of what I would call vanilla digital chip design is almost like writing code. You write a piece of code that describes the function or the structure, and you effectively compile it into hardware instead of compiling it into a program. It's pretty close to that these days. Now, analog circuits are a little different. Of course, they're still circuits. They still work with the same currents and voltage concepts that we're about to introduce in the next few videos. But the idea here is that they're not binary. They're sort of continuous. You can think of, the easiest way to think about it is, let's say the current coming out of a microphone, right? Actually, my voice is producing some sort of disturbance in some mechanical component, and that mechanical component producing this time-varying current, which maybe I then want to do something with.
So I'm sort of drawing a current here. You can sort of get a waveform that is varying, and it's a continuous waveform. It's not just zeros and ones. It's more complex.
Yeah, it can be, right. And so you might ask, well, in what context is this used? It's really used all over the place. And this is kind of the heart of this course. There's some really nice courses on digital, in particular one from UT Austin. But we're going to be focusing on this analog side. The reality is that all of the digital stuff, the digital fabric, let's call it that, has to talk to the real world in many, many ways.
Okay? And the real world is continuous.
And the real world is continuous.
Yeah.
Although there's a nice little philosophical aside we could do about whether physics is really continuous, but let's not get into that.
You can go to quantum mechanics if you want. But.
Okay. Anyway, but the fun part is, yeah, to our for zeroth order, it's continuous, and so all the time we're required to build circuits that are interacting with us. Okay, think microphones. We talked about this in some of the intro videos. Microphones, antennas, all the radio frequency stuff, light. So what do we do? And what do we use analog circuits for? Largely to amplify, to filter, and to sort of manipulate and condition these signals prior to being put into the digital fabric for computation. That's not the only use, but that's the workhorse in the industry.
I see. So in this class, before we send signals to the microcontroller, we need to do this processing to the signals in the analog.
Or sometimes the other way around. Sometimes after the digital fabric is done with something and wants to output, right, then you're doing that on the back end, if you will. Okay? So the thing to remember is that analog circuits, you do have to be careful about things like noise and distortion, but also interestingly, and outside of the scope of this course, really elite analog circuit designers often make use of noise and distortion and interesting nonlinearities and all sorts of cool things to do really whiz-like circuits. But the reality is that, or the consequence of all this is that analog circuits are not as trivially composable or modular, and it does largely still rely on people that are very good at knowing how to do this. It's sort of the whiz analogy. Now, last thing I want to tell you about this is in modern practice, the combination of analog and digital, knowing how they all come together to build what are called mixed signal chips, right? Chips that do both. That's really what everybody does. So you have to be good at kind of putting together or have somebody on your team that does all the vanilla digital, but you have to be able to do these, really clever sort of analog parts, these interfaces.